So the test being on Monday, we are just about done with the chapter. We just want to go over this last concept we did yesterday. I just want to show you one more thing. There's not really notes that go with the last part. And then that's it. We're going to hopefully be able to get to a review game tomorrow. So we're going to start right off here. When the river is going 100 centimeters per second with multiple choice here, the answer should have been 3 pebble. You guys good with that? Did you get that? Some of you did. All right, number 2, when when a river is moving 200 centimeters per second, that will be 2, a cobble. Nope, I said cobble. Yep. Number 3, so how fast does the river have to be moving this time to move a 1 centimeter particle? And that will be 1 centimeters per second. So I see a whole bunch of people changing their answers for that one. So let's just double check. So this time they told us the river was moving, right, 1 centimeter per second. Is that what one was? Yep. No, we have a centimeter size particle, which is what I'm pointing to. Move your pen over till you hit the line. Go down, that hits right near 50. And that's what we got going on here. Number 4, when it slows down from 300 to 200 centimeters per second, what will be dropped off? That is answer 1. That's when the boulders get dropped off. So when a stream is moving 300 centimeters per second, it can carry the boulders. But when it drops to 200 centimeters per second, it's going to drop off the boulders. Everything else is still being carried around. Number 5, as velocity decreases, the amount of sediments transported will also decrease. And number 6, when the water velocity slows down when it enters into the lake. I'm sorry, that's not the question here. So which factor most likely caused the sediments to be sorted? And that's because the water velocity slowed down. So notice we first had gravel, then sand, then silt, then clay as you go into the lake. And then as one moves to the right along the stream velocity axis, oh my gosh. So as we go to the right, what happens? So the water speeds up and there'll be more erosion. So that's going to be classified as erosion because water is moving faster. Questions so far on the front? Did you try? Did you use the reference table? Yeah, I mean, you can't get them right if you don't use the reference table. Number 8, when we are moving at 75 centimeters per second, that will be able to carry pebbles, sand, silt, and clay. So basically not cobbles and boulders is the only thing. Number 9, we have a velocity of 100 centimeters per second, which will most likely deposit first as it enters the lake. That's going to be pebbles. It's not boulders and cobbles because they're not being able to be carried in the first place. So since it's only going 100, we can't be carrying boulders and cobbles. Pebbles are the biggest thing it can carry. So as it slows down, they'll be the first things to be dropped off. Number 10, as a stream increases from 5 to 30, which order will the particles of different sizes begin to move? That's going to be first the sand, then the pebbles, then the cobbles, then the boulders. Number 11, which one will be suspended the longest? That's going to be the smallest, which is clay.
Oh, got it right.
Nice guessing. Number 12, so we have here, again, a river entering a lake, and then they give you the size of the sediments in each area. So then we want to know which one's going to become siltstone. Well, that's the silt-sized particles. So silt is anything from 0.006 to 0.0004. So which ones will be silt size? That's answer 3, which is area here. So this area will become siltstone because those are silt size sediments. And finally, number 13, we got which one represents the relationship between velocity and the diameter. So again, we read this by saying, as the velocity increases, particle diameter, line going up, increases. Answer 1. Does anybody, I know I just went through those really fast trying to save time. Does anybody need me to go over any of them in particular? Good. Nobody needs any of those in particular? Perfect. So then what we got to do is just look at the last set of pictures in our packet. So that will lead us to this page. And this page looks like I wanted to take some notes on it, and I really don't. The types of questions that will be asked about stream drainage patterns are really, really, really quite straightforward. What do I mean by that? Is we don't need to take notes. What I'm showing you here, 27. So it should be the last, almost the last page. So these are, what we've got going on here is this set of pictures is supposed to represent what the land looks like. This set of pictures is supposed to represent what the rivers look like on that land. Now they do have names. I have never once seen the names given on the Regents exam. All I've ever seen them do is give you a picture of the land, and you have to match up what the rivers are going to look like on that land. So let's start with this first one. What do you see in this picture? What's the land looking like here? What's this going on? I wouldn't say a volcano because volcanoes usually have craters. If anything, I would call this one a volcano that's got a crater in it here. Oh, I'm sorry. I'm missing this one in the picture. So I do see why you said a volcano for this one, because it does have that dip down. But again, it doesn't have the crater like this one. This just has, you can see that the land is higher in the back here, a little lower here. Yes, there is a little bit of a depression here. All you got to do is the water's going to flow downhill into one main source here. So you got to be able to match that one up with that. This one, again, this one has like a dome, almost like a little hill in the background. The water will come off that dome down each side of the hill. This one, we've got these craters, so the water will kind of flow into the craters, making that circle shape. And then here we got these parallel hills here. You get parallel streams coming off of them. Again, you just have to match up the land with what the water will look like coming off of that land. Not overly complicated. Okay, that's it for the chapter. I want to review one more thing that we did yesterday before we get into the big review. So turn back to page 25. This is where we are learning about the river. Instead of having you guys work together like we attempted to do yesterday, here is the actual river in front of you. And I'm going to have you guys calculate the gradient of the river between points A, is it A? A and E. So the very last question, very last question on page 25. You will technically use a calculator. If you don't have one, you can come up and grab one for this because it's gonna be real quick. Why don't you go ahead and use your phone for a calculator? This is a real quick assignment. So calculate the gradient. If you want a piece of scrap paper, they're up here. You guys can come help yourself. Or you can just use any piece of paper you own. So go ahead and calculate the gradient on the Ritz River between points A and E. You have to get your AirPod out. Like, I do your AirPod again, I'm gonna have to take it. Yeah. Yeah, I'm not sure why I said A to E double time there. Just do A to E. Sorry. If you already did A to prime, A, E prime, do that too, whatever. It doesn't matter to me. Either one's good. Does that help your question, Ryan? I think that was a typo. Okay.
Yeah.
So remember how we calculated the distance yesterday to measure this? So for those of you struggling to calculate the distance, again, remember we cannot just go straight across the river with the scrap paper and go A to E. That's not the way the river flows. The river does not flow straight across the paper. So you do have to go at an angle between the different points as best you can. So I'm gonna go from A to B, keeping B held steady. I'm gonna just adjust it to go to C, cross this off, adjust it again to go, keeping C at the exact same spot, going to D, and then going D to E. So you can see that that was quite a bit different than going straight across, not a huge amount, but it definitely was a little bit different. Once you have those marked down on your paper, bringing them to the scale, you'll see that it is longer than 8 kilometers. So you have to kind of adjust for that. So I'm marking off the 8 kilometers and then starting over. Now, instead of this being 1 kilometer, when I start over, the 8's on the 0, this is 9, 10, and I'm right at 11 kilometers for mine. You guys might have got something slightly different, but I did get 8 kilometers for my distance. Is that kind of close to what you guys had? Okay, perfect. So when you plug that into the gradient formula, which is change divided by distance, that's the bottom number, 11 kilometers. How do you get the change?
You just subtract 500 by 106.
500 minus 106. And did you get an answer?
Yeah, I got 394 divided by 7 equals 56.3.
Oh, you had 7 kilometers?
Yeah.
What did you guys have? Right. Yeah, you redo your 7. There's no way it was 7. That'll definitely make a difference. So 394 divided by my 11 gives me 35.818181. And I said this yesterday, the regents will tell you to round however they want you to round. Most likely it will be to the 10th place. The 10th place is the one number after the decimal. In this case, it's an 8. Does it stay an 8 or round up to a 9? Stays an 8 because the 1 is not bigger than 5 or 5 or bigger, so it stays the same. This is 35.8, and you must include the proper units when doing gradient. Meters, careful with that. It's meters per kilometer. I know. I just wanted to make sure. If you did write miles per kilometer, I'd have to mark it wrong, which would suck because I know you obviously knew that was just a mistake. If you're never sure of how to abbreviate, then don't. You can write out the word meters/kilometers, especially with miles. Always remember miles is abbreviated MI, not just M. So that's how we do the gradient. Now in our class, did we get to all of the 5 pictures on the back? We did. Okay, so let me just, I don't remember honestly how that went down. It has my papers fall on the floor. So yeah, we must have done them all together yesterday. But again, remember how we work this out is you put the dot closer, the deepest spot goes closer to the outside of the curve on a curve. So A, it was closer to A prime, which gave you a gentle slope and then a steep slope. B, because it was a straightaway. So anytime it's on a straightaway, the dead smack center is going to be the deepest spot. So with B, the dot's in the center, and they come down looking like pretty much a perfect V. C, the outside of the curve was near C, so again, put the dot over there. We've got a steep, then a gentle. D was on another straightaway, so it's in the center. E, the deepest spot should be closer to E prime. Let's do the conclusion. In 1 or 2 sentences, explain how the stream shape would be different if the gradient were changed. What would it look like if the gradient were doubled? And what would it look like if the gradient was cut in half? So what's changed when the gradient changes? Okay, the slope changes, and because when the slope changes, what changes? The velocity of the river. So if the river is moving faster, what's going to happen to our curvy river? So is it going to get more curvy or more straight? It's actually going to end up straightening itself out. If it's going faster, it can't really handle these curves. So it's going to wear away. And remember, we also learned that at the beginning of this section, that the faster the stream, the straighter the stream. And basically what happens is it's going to end up skipping over some of these. So instead of following the curve here, if this was moving so fast, it's going to end up going straight, potentially causing that oxbow lake. So if we make it go faster, it's going to go straighter. And what happens if we slow it down? What happens when rivers slow down? They gets more curvy. I don't think that will be, I know that won't be on the test on Monday. That doesn't seem like a Regents question either. I just kind of wanted you to think through it. Okay, that was a long chapter. I feel like we've been doing it forever. And we need to be done with it. So we are going to just be done with it. And hopefully I ended up getting enough copies. As always, we're going to do one of these review sheets, but I set it up this time. I also have some review questions on here. And I also noticed it printed really stupid with the staple on the bottom. That would be me making a mistake in a hurry. So if you want to change the staple, you can do that, obviously. We are not going to do all of these review questions. If you, could just, if you wanna leave the Ritz River on your desk when you leave, that is, perfectly fine with me, cause you don't really need to take that home. So I like these review sheets because it takes, basically sums up the entire chapter in one sheet of paper. Would you guys rather work on these on your own or together? Or like partners? You wanna do that? Okay, so for homework then, which means you're starting it now, and you can work with a partner, you're going to finish the review sheet, front page and back page of the review sheet. And let's do questions 1 through 11, but here you can skip question 2. Don't do question 2. So questions 1 through 11 and the review sheet are homework. I'll write that up on the board to just double check, and just to remember, it's always posted on Teams every night what homework is. So you have the rest of the period, you have about 10, 15-ish minutes to finish up this review sheet and questions 10 through 11. Yeah, you're just not putting enough effort into that one. That one requires muscles because it's for a big packet.